Today we're going to be working on Lesson 40, which is found on page 208 of your text. In this lesson, we're going to work a little bit more with decimal numbers, and then we're also going to look at circle graphs. Let's go ahead and get started. In Lesson 40, we're again working with decimal numbers. Consider example 1. We're asked to take 5/10 and subtract from that 32 hundredths. Well, notice that if I line up my decimal points for the subtraction, I'm missing a place here. So I'm just going to put in a 0 here before I subtract. Then we can just subtract. So we have, let's see, we need to borrow. So 10 minus 2 is 8, and 4 minus 3 is 1. So then our difference would be 18 hundredths. And again, if you'll look at example 2, we're going to be subtracting from 3 4/10. So we're going to write 3 as 3 and 0/10, and then we're going to subtract. 30 minus 4 is 26. So 3 minus 4/10 would be 2 and 6/10. Now we're also going to be multiplying numbers, and we're going to have to insert a 0 as what we call a placeholder. Consider the following. If I take 2/10 and multiply that to 3/10, well, notice how I have 2 decimal places in my factors. So that means I will need 2 decimal places in my product. But when I multiply 2 times 3, I only get the single-digit number 6. So in order to have 2 decimal places, I'm going to have to insert a 0 as a placeholder before I can put down my decimal point. And this answer would be 6 hundredths. So we would have 2 places here. Just make sure that you insert the 0 as you move to your left. And don't put it past the 6 because that wouldn't change. That would change the value of this. Well, then let's look at example 4. In example 4, we're asked to use digits to write the decimal number 12 thousandths. Well, 12 thousandths. Consider what this means as a fraction. It's 12 over 1,000. So we need to have 3 places when we write this number, but the 1 and the 2 will only take up 2 of those places. So what I'm going to have to do is insert a 0 as a placeholder before I put down the 12. And so then this is the number 12 thousandths. Now compare this to the number 0.120. This is 120 thousandths. So be very careful in how you write this. If you need an extra 0 in here to fill a place, make sure you put it between the decimal point and your other numbers. And this is 12 thousandths. Now we're going to be also looking at circle graphs. Circle graphs are sometimes called pie graphs because they look like pies. And what we're going to do is just look at a circle graph that is going to be giving information about neighborhood pets. In example 5 at the top of page 210, it says, Brett collected information from people in his neighborhood about their pets. He displayed the information about the number of pets in a circle graph. Use the graph to answer the following questions. Well, if you'll look at the graph is a circle graph. So to copy it, we would want to make a circle. This is the radius of the circle. And notice that a diameter has been drawn like so. Now that splits a circle in half. And so it appears that dogs make up half of the pet population in the neighborhood. Then we have another radius that is drawn here, and we have cats listed. And cats, there's 8 cats. And then we have another radius, like so, and this is labeled birds, and there are 4 birds in the neighborhood. And then fish, well, 4 people have fish in the neighborhood. Okay, so look at the questions you're being asked in example 5. It says, first of all, how many pets are represented in the graph? Well, 16 dogs, 8 cats, 4 birds, and 4 fish have a total of 32. So there's 32 pets represented by the graph. For part B, what fraction of the pets are birds? Well, out of 32 pets, 4 of them are birds. So that's 4 out of 32. 4 divided by 4 is 1, and 32 divided by 4 is 8. So 4 over 32 would reduce to 1/8. And so birds represent 1/8 of the pets in the neighborhood. C, what percent of the pets are dogs? Well, out of the 32 pets, 16 are dogs. And 16 out of 32 is the same thing as the fraction 1/2. That's what I told you, that if you have a diameter here, that's dividing the circle into 2 equal halves. So dogs are representing 1/2. And you know from our studies that 50% is the same thing as 1/2. So 50% of the pets are dogs. Okay, so we're working some more with decimal numbers, and now we're also looking at circle graphs. Now, since circle graphs are used also to help us understand percents, many times when you look at a circle graph, it will be divided up into percentages rather than just strictly numbers. So remember that when you're working with circle graphs. Many times these graphs are used to show percentages. Well, let's go ahead and let you try your practice problems, and then when you finish those, come back and we'll work on those together. Okay, so how did you do with your practice problems? Remember that when we're working with circle graphs, many times these graphs are divided up into percentages of a whole, in much the same way as you've been working with your fraction manipulatives. Well, let's try your practice problems and see how you did. Practice problem A says to simplify, and we're asked to simplify 2/10 times 3/10. Well, 2 times 3 is 6, but we need 2 place values here and here. So we would want to, as we count our places as we're moving to the left, insert a 0 as a placeholder. And then our product would be 6/100. Problem B, we're asked to take 4 6/10 and subtract from that 46/100. Well, we would need to insert a 0 as a placeholder before we subtract. And then we would want to borrow, subtract, and our difference would be 4 14/100. Problem C, we have 1/10 being multiplied to 1/100. Well, 1 times 1 is 1, but we need to have 1, 2, 3 decimal places. So 1, 2, 3. So we'd insert 2 zeros, and our answer would be 1 1,000th. Problem D, we have 4/10, and from that we are subtracting 32/100. So we would add a 0 here, and 40 minus 32 is 8. So 40/100 minus 32/100 is 8/100. And so 8/100 would be our answer. Problem E, we have 12/100, and we're multiplying that to 4/10. Well, 12 times 4 is 48, but we have 3 decimal places in our factors, so we need 3 in our product. So we'd have to insert that 0. So 48,000ths would be our answer. Problem F, we have 1 whole, and we're taking away from that 98/100. Well, 1 whole is the same thing as 1 and 0/100. So then we would subtract. Now, 100 minus 98 is 2, so keep that in mind when we're working this. I'm going to borrow. 10 minus 8 is 2, 9 minus 9 is 0, and 0 minus 0 is 0. So 2/100 would be our answer. Okay, let's look at problem G. For problem G, we're asked to take 3/10 and square it. So that's going to be 3/10 times 3/10. Well, 3 times 3 is 9, but we need 2 decimal places, so 1, 2, so we'd have to insert a 0. So 9/100 would be the answer. In problem H, we have 12/100 that is being squared. So this is going to be 12/100 times 12/100. Well, 12 times 12 is 144. But we need 1, 2, 3, 4 decimal places. So 1, 2, 3, 4. And then, of course, our customary 0. So 144 10,000ths would be how you would read that number. Problem I. Write the decimal number 10 and 11 thousandths. Well, 10 and would be the whole number 10 and then a decimal point. 11 thousandths. Well, 11 thousandths needs to have 3 decimal places. But the 11 will only take up 2 of those, so we'd have to insert a 0. So this is 10 and 11 thousandths. In problem J it says, in the circle graph in example 5, what percent of the pets are cats? Well, according to that graph, 8 of the pets were cats. That was 8 out of 32. And 8 out of 32, if we reduce that, 8 divided by 8 is 1, and 32 divided by 8 is 4. And then you know from your fraction manipulatives that 1/4 is the same thing as 25%. So you should have said then 25% as your solution. And that's it. Well, have a wonderful day and enjoy your math, and I'll see you tomorrow.